Hey there, today I'm going to give a short demo of the four main C++20 features in Visual Studio. Those are coroutines, modules, ranges, and concepts. So what I've got right now is an implementation of a generator type. If you're familiar with a Python generator, it's much the same thing. This is based on C++20 coroutines. It's also compatible with ranges, and it's using modules. It's exporting a module called generator. And then the single type which it exports is called TL generator. Now what I want to demo today is I'm going to implement IOTA, where IOTA is a function template which is going to give you back something which counts up in increments of 1. So if you start with 0, then it's going to give you 0, 1, 2, 3, 4, 5, 6, so on and so forth. Could start at 20 and give you 20, 21. Get the picture. And I'm going to implement this using my generator type. Now I want IOTA to be exported as a module, so I'm going to go and create a new item. One of the options down here now is C++ module interface unit, which has an IXX extension. So I'm going to go ahead and create an iota.ixx. This will create a new file which is exporting a module called IOTA. Now I want a single function template which I'm going to export, which is going to be called TL IOTA. So I'm going to have namespace TL export, because I want to export this from the module. It's going to be a template. I want to take anything which is an integral type, which I can use std integral for in concepts. It's going to return a generator for T. This is where all of the magic for coroutines happens. It's all in the return type. It's going to be called IOTA, and I'm going to take a T, or you can just pass nothing and it will default to 0. Okay, so I've got a few errors here because I haven't included ranges and I haven't imported my generator type. You can see if I hover over here, it gives me an error. So you might think that I want to hash include ranges here. This is actually subtly wrong. Anything underneath this export module will have module linkage, and we don't want everything in this header file to have module linkage. We'll get some weird compiler errors. The way to get around that is put it in the global module fragment, which you do with a single module semicolon, like that. We're also going to need to include coroutine, and we want to import generator. And if we save this, there we go. IntelliSense just found std integral in the ranges header, and we should hopefully get TL generator soon as well. Note if I control click on this import statement, this is going to go and look for the generator module. And it's taking a little while because it's having to scan for all the dependencies and all of the modules in the project. The next time that you do this, it will be a lot faster. And if I run a build first, then it would, but there we go. We got our generator module. So that's handy. For example, if I do this again, then it goes pretty much instantly because it's already worked out the dependencies. And you can see that IntelliSense has now found TL generator. We're all good. Okay, so our implementation of IOTA, we're going to loop infinitely. You could give this a bound or end. I'm just going to count up infinitely. And we're going to co-yield back n and then increment it. So all this looks like a infinite loop, and it is. This function's not going to hang when you call it. Whenever it gets to co-yield, it's going to suspend, return back to the caller, and then this function can then resume later when it's asked for. So this will stop in the co-yield and then loop round whenever you ask for a new value. That's what the TL generator is going to be doing. Okay, so we've got modules, we've got our generator, which is built in coroutines. We can go and test this out. Okay, so in our generator test, we're going to import IOTA. We're going to need ranges, we're going to need coroutine again. Note that we do not get the imports, the hash includes from here. This is all like firewalled. So one of the actually good things about modules. And I'm also going to do some output, so I'll include outstream. Okay, I'll just have a single main function, and we can test out our iota like this. For I in TL iota, start off at 10. Oops, stood cout I. And a space. Okay, so this will never stop, right? Because TL iota is going to loop round and we'll just get 10 up to, you know, when this loops round, and we don't want that. So let's pipe this. Like I said, this is ranges compatible. So we can say std views take 10 to take the first 10 items from this range. So now if I go ahead and compile this, so what this is going to do is call TL iota, which will get us back a generator. It's going to pipe it into views take, and now whenever we go round in this loop, something's going to be dereferenced internally, which is going to cause the coroutine, which we defined here, to drive forward and give us a new value. And then take is going to make sure that we finish once we've got 10. So this is kind of a nice way to compose things. This is the value proposition of ranges. This is a kind of a silly example, but you can see how you could compose these things as much as you want. And also the implementation for iota is way smaller than anything you would write by hand for ranges, which would be, a couple hundred lines of code or something. It's about 15 with all of the includes. Okay, so that succeeded. We can go ahead and run this, and hopefully we should see 10 through 19 being printed out to the console. 10 through 19, there we go, 10 through 19. Okay, now say that we want, like right now this takes any integral type. Maybe we have something which, acts like an integral type, but isn't. Maybe it wraps some integer into could have other things, basically anything which you can increment and subtract to take the difference between. So say we have int which has some internal integer, and it has a operator ++, which you can use to increment it. And then we also need a operator ++, a post increment operator, which makes a copy first, and then increments, and then returns temp. And then we want to be able to take the difference between two. Friend auto operator minus takes a couple of int likes and returns the difference. Whoops. And just return a.i minus b.i. Okay, so if we compile this right now, then we're expecting to get an error because iota says it requires something which is integral type, like int or short or long, and we've given it something which is not an integral type. So we're expecting a compiler error here, and this is concept. We're constraining this function template. Oh, we're getting a different error. I must have class type. Oh, I need to give it int like here. Yeah, so we're expecting an error here because int acts like we want. All we really need is to be able to increment this thing, but it's not an integral type, so the compiler is going to give us an error. One other thing to note here, if I look at my output, is this is scanning for module dependencies. This means that the build system is doing all of the dependency handling for us for these modules. We're not going to have to tell it in which order to build these modules and things like that. It's going to work it out automatically, which is very nice. And you can see here in our errors, we did get no matching overload found because the associated constraints we're not satisfied. So that's what we expect. That's what concepts gives you, the ability to constrain functions, and for the compiler to tell you that something went wrong. You didn't have the right constraints satisfied. We can fix this by changing this to weakly incrementable, which basically says you can pre-increment it, you can post-increment it, you can find out the difference between two values. Slightly weaker than incrementable. The difference between the two is weakly incrementable supports single pass operations, whereas incrementable allows you to do multi-pass. So this is going to go ahead and compile again, and hopefully this will succeed, and we will print out, because we're starting at 0, then we'll get 0 through 9. So again, this is scanning for dependencies. We forgot to return a value here. Return this. There. It's one thing I always forget when doing things like that, returning this. This is going to go ahead and rebuild. And one other thing, like I mentioned, you can control click on generator here and it'll go to your module. The go-to definition will also work. So if I go ahead and control click on generator, then this is going to take me straight to the implementation for a generator type. As soon as IntelliSense works out where we're going, there we go. Okay, that succeeded. We can now run this. And we should see 0 through 9. There we go. Okay, that all worked. So that was my Whirlwind demo of the main C++20 features inside Visual Studio. Please do give it a try. Let us know if you find any issues. We'd love to hear your feedback. We'll be continuing to work on the IDE experience to make it the best we can. And also please do check out Pure Virtual C++ on the 3rd of May, where we'll be talking a lot more depth about modules in particular, and also our general C++20 progress. So thanks very much. I'll see you there.